Now here's 3.7.10. So we're given this function f of x, e to the x squared minus 1. And now this function, you're not necessarily supposed to know what it looks like, but you should be able to know that this function is what's called an even function. An even function means that if I get whatever x value I put in, like 1 or 7, I get the exact same value as if I put in -1 or -7, which means it's symmetric. So my guess is, since I plug in 0, I get 1, and 1 minus 1 is 0. My guess is that the function looks like this, but you don't have to know that in order to do the problem. However, what you do need to know is that this does not pass the horizontal line test, which means that this function does not have an inverse. Or it does have an inverse, but it's going to be split into two pieces. So that's why this x plus x is greater than 0 is here, because we're only going to look at this piece, which means the inverse should be something like that. Alright, so now we can get started. Give some little insight to the problem. So in order to find an inverse, we need to switch x and y. So x equals e to the y squared minus 1. Now I'm going to add 1, so I get x plus 1 equals e to the y squared. Take ln of both sides. X plus 1 equals ln of e to the y squared. This comes down, and ln of e is 1. So ln x plus 1 of y squared. And then square root. So we get plus and minus the square root of ln and then square root. So we get plus and minus the square root of ln x plus 1, which equals to y. So like I said before here, the plus piece will be the piece that I just drew, and then the minus square root will be this piece. Well, since the inverse is greater than 0, then I only want this piece. But if it said less than 0, then I would take the negative. So all I want is the positive. So the domain, state the domain and range of f inverse. So we're looking at this red one here. The domain is x is greater than 0, and the range is y is greater than 0.